In 1938, in Berlin, inside the halls of the Reich Aviation Ministry, a group of officials gathered to review blueprints for a new piece of machinery. The project presented sparked confusion among those present, as the proposed technical solutions differed radically from accepted aviation standards. The concept called for an asymmetrical aircraft design. The cockpit was shifted to the starboard side, while the engine was positioned on the left, rather than along the fuselage's central axis. The meeting participants expressed serious skepticism regarding the machine's aerodynamic qualities, voicing fears that such a layout would cause the aircraft to roll over during takeoff and pose a threat to the pilot. Despite the critical assessment from the officials, the design's author, 40-year-old engineer Richard Vogt, insisted on the accuracy of his calculations. Vogt, who had piloting experience from the First World War, held a reputation as an engineer prone to seeking non-standard paths and implementing innovative solutions in defiance of traditional approaches. The story of this aircraft's creation had begun several months earlier, with the announcement of a competition to develop new equipment. The technical assignment contained a number of strict requirements. The projected machine had to be a single-engine reconnaissance aircraft, with a crew of 3, providing an excellent field of view for observation, as well as possessing high speed and maneuverability. The client specifically emphasized the single-engine layout to simplify the production process and reduce fuel consumption. Leading aircraft manufacturers, such as Arado and Focke-Wulf, were invited to participate in the competition. The company Blohm Voss, where Vogt was employed, did not originally receive an invitation, as its specialization was building seaplanes and flying boats, not land-based reconnaissance aircraft. Nevertheless, Richard Vogt decided to participate in the development, as he had long been analyzing fundamental questions of aircraft layout and saw an opportunity to apply his theoretical work. In the aviation industry of that period, the standard symmetrical scheme prevailed. The engine was located at the front in the center, the cockpit behind it, the wing in the middle section, and the tail assembly at the rear. This layout was considered the accepted norm, yet engineer Richard Vogt noted a number of technical flaws in it. First, the engine placement limited the view for the pilot and observer in the forward hemisphere. Second, the airflow from the propeller impacted the control surfaces, destabilizing flight. Third, the engine's torque created a pulling effect, requiring the pilot to constantly correct the course. Thus, geometrically symmetrical aircraft demonstrated asymmetrical behavior in flight, complicating control. Vogt put forward the concept of creating a plane with an asymmetrical construction that would actually ensure symmetrical flight characteristics by compensating for these forces. Walter Blohm, the company owner, supported this proposal. With an eye on the long-term prospects of civil transoceanic transport, he viewed military orders as a temporary stage and encouraged innovative technical solutions capable of boosting the enterprise's competitiveness. Despite the lack of an official request from the Aviation Ministry for such a machine, management approved the project, seeing both engineering and reputational potential in it. The design group set to work. The design called for the BMW 132 engine to be placed on the left side in a separate fuselage that extended back into the tail section. On the right sat a fully glazed plexiglass gondola for the 3-man crew, the pilot, observer, and gunner. This compartment was attached to the wing, offering a high level of visibility in all directions, including the upper and lower hemispheres, as well as the area to the rear. When it came to visibility, the machine outperformed existing single-engine counterparts. The wing connected both parts of the structure. Its parameters were calculated so that the lift distribution would offset the asymmetrical weight placement. To confirm the plane's stability in flight, Vogt performed the necessary mathematical calculations. Assembly of the first prototype was finished by the end of 1938. When the ground crew rolled the machine out onto the airfield, its unusual design grabbed everyone's attention. Because of its asymmetry, the plane looked like a combination of parts from two different aircraft. Before taking off, the test pilot performed a thorough inspection, expressing some skepticism about the design's aerodynamics. The ground team was also uneasy, speculating about potential trouble during takeoff or a loss of stability. Designer Vogt watched from the sidelines, realizing that the future of the project and the entire concept of asymmetrical aircraft depended on the success of this first flight. After the engine started, the takeoff run began. Despite the vibration, the machine held its course and successfully lifted off the runway. The flight went according to plan, with the plane climbing confidently and disproving the pessimistic forecasts. The pilot circled the airfield, performed a series of maneuvers, and landed safely. Leaving the cockpit, he gave the flight qualities a high rating. There were no issues with rolling, control was crisp, and the view from the glass gondola was better than standard models. News of the successful tests spread quickly through the aviation world. One of the figures who took an interest was Colonel General Ernst Udet. With his significant piloting experience and interest in technical innovations, Udet requested a personal demonstration of the plane, which had received the designation BV-141. The designer organized a showing where the general inspected the hardware and personally took part in a flight as an observer. Following the demo, Udet gave the machine a positive review, noting that it met ministry requirements and even exceeded them in several ways, after which he promised the project administrative support. However, there were other viewpoints within the Luftwaffe High Command. Hermann Goering was critical of the asymmetrical layout. A supporter of traditional solutions in aircraft construction, he characterized the project as a technical curiosity and expressed doubt about the wisdom of adopting it. Göring preferred the competitors, specifically the Focke-Wulf Company, with their Fw-189 reconnaissance plane. That machine featured a twin-boom design and two engines. Even though the technical specifications called for a single-engine layout, the command viewed the twin-engine scheme as more reliable and safe. Also participating in the competition was the Arado Company with the AR-198 project, which the ministry had initially considered the priority option. The management had tentatively approved the contract with Arado, but once the prototype was built and tested, it became clear that the AR-198 had significant flaws: poor flight characteristics and instability in the air. As a result, the project was shut down, and the clients turned their attention to Focke-Wulf. This gave the alternative asymmetrical design a chance to prove its worth against its twin-engine counterpart. On April 4, 1940, comparative trials of the BV-141 and Fw-189 took place. The commission arriving at the proving ground evaluated the technical parameters of both models, including speed, maneuverability, stability, cockpit visibility, and suitability for reconnaissance from various altitudes. Although both aircraft demonstrated solid results, the BV-141 held a number of design advantages. The use of a single engine simplified maintenance and lowered production costs. The view from the glazed gondola proved to be more comprehensive than that of its competitor, thanks to a larger area of transparent elements and the lack of obstructions. Furthermore, the asymmetrical machine demonstrated high maneuverability, dispelling doubts regarding the reliability of such an aerodynamic layout. In its final report, the Commission noted the aircraft's suitability for the assigned tasks and its high potential. Ludet used this data to promote the project within the ministry, arguing for the necessity of adopting such equipment into service. Despite opposition favoring the FW-189, the Air Ministry made a decision to place an order for 500 units of the BV-141. This marked a significant achievement for the Design Bureau and the Blohm Voss factory. The aircraft, whose unconventional design had previously invited skepticism, was approved as a mass-produced reconnaissance plane. Plans were made to deploy the equipment across various operational sectors, including the Eastern Front, where large-scale operations were anticipated. For the developers, this meant the successful conclusion of the design phase and the securing of a major long-term contract that would keep the enterprise running for a long period. Preparations for serial production began. New workshops were erected, equipment was purchased, and the workforce was expanded. At the same time, work continued on modifications, featuring more powerful engines and reinforced weaponry. The new reconnaissance aircraft was expected to occupy an important place in the aviation fleet. Military specialists developed deployment tactics, trained flight crews, and planned operations to scout enemy rear areas and supply lines. However, the optimistic forecast soon gave way to difficulties. As they delved deeper into the manufacturing processes and the construction of new models, serious technical issues began to surface. Problems that had either not been recorded previously or had been considered insignificant. The first substantial problem concerned the crew compartment. The fully glazed gondola, which provided excellent visibility and was considered the BV-141's primary design advantage, offered poor protection in combat conditions. The glazing, even with armored sections, could not guarantee the safety of the pilot, observer, and gunner against projectiles. Enemy fighters or anti-aircraft guns could inflict critical damage on the cockpit in seconds. The crew found themselves highly vulnerable to enemy fire. Consequently, military pilots began to express doubts regarding the safety of operating the aircraft. Reports emerged that some pilots were unwilling to fly missions in a plane that was so visually conspicuous, yet offered such insufficient protection. The second issue was technical. The rudder on the tail assembly was suffering from excessive aerodynamic drag. Airflow from the propeller and the asymmetric fuselage created turbulence that made the plane hard to handle. Holding a steady course, especially at high speeds, took extra effort. While this wasn't seen as critical during short test flights, on long reconnaissance missions, that constant physical strain would lead to pilot fatigue and a drop in the crew's overall efficiency. Engineers tried adjusting the shape and size of the rudders, but every change brought new balancing problems. A third problem cropped up after the machine guns and extra equipment were installed. With the added mass, it turned out the wing wasn't long enough to maintain the right balance. The right side, housing the cockpit, gondola, and weapons, started outweighing the left side with the engine. They had to lengthen the wing, which in turn increased the overall structural weight and dragged down the speed. Fixing one flaw just led to new technical challenges, turning the modification process into a vicious cycle. It was becoming obvious that a project which had shown such promise early on was transforming into a complicated machine requiring constant compromises. Nevertheless, work continued. By 1941, 3 prototypes were ready for in-depth testing, along with a batch of 5 version A aircraft for field trials. These planes were equipped with BMW 132 engines, putting out 1,560 horsepower, giving them a top speed of about 272 miles per hour. The flight range was roughly 1,180 miles, with the service ceiling reaching 31,800 feet. These specs were considered acceptable for a reconnaissance plane, but the client came back with additional demands. They wanted a more powerful engine, higher speed, and better crew protection. In response, the B modification was developed, positioned as the main production model. The BV-141 version B underwent significant changes. The biggest upgrade was the installation of the 1,560 horsepower BMW 801 engine, which helped boost speed. The tail section was redesigned and became asymmetric. The right side of the horizontal stabilizer was removed to give the rear gunner a better field of view and fire. This engineering choice highlighted the aircraft's unconventional layout even more. The layout placed the engine on the left and the cockpit on the right, and now the tail section was asymmetric as well. Armor on vital components was reinforced, though fully protecting the glass gondola was impossible. The weaponry was upgraded, adding machine guns to defend against fighter attacks. By the end of 1941, 12 production models of the version B had been built and put through a cycle of intensive testing. The results were mixed. The new engine certainly improved speed and maneuverability, but concerns about crew safety remained. On top of that, the complex design made production labor-intensive and expensive. Assembling the BV-141 required significantly more man-hours than building classic symmetrical aircraft, because, due to the asymmetry, almost every part was unique, with practically no interchangeable components. This circumstance complicated logistics and expanded the inventory of spare parts, slowing down production rates. Ultimately, the Air Ministry came to the conclusion that the BV-141 was technically too complex for mass manufacturing. Under the circumstances, which demanded a rapid replenishment of the fleet, the unconventional design was deemed cost-prohibitive. Another factor was the critical need for BMW 801 engines for the newest Focke-Wulf 190 fighters, which provided air defense. Resource allocation for fighter aircraft took priority over the production of experimental reconnaissance planes. Leadership decided that the existing Focke-Wulf 189s were successfully handling reconnaissance missions, and retooling established production lines wasn't expedient. The order for 500 units was cancelled. Production halted with just a small batch. According to archival records, counting all prototypes, only about 20 machines were ever assembled. For the design bureau led by Richard Vogt, this decision meant the end of a massive undertaking. Years of work on blueprints and fine-tuning a machine that was seen as a promising replacement for existing models failed to result in mass production. Despite the program's cancellation, Vogt continued to refine the design, hoping the ministry might reverse its decision. Documentation was prepared for 38 different modifications of the BV-141, with various power plants and onboard equipment, But these designs never left the drawing board. Eventually, the project was shut down completely due to the shifting strategic landscape. In 1942, Allied air forces launched a massive strike on industrial targets, one of which was the Focke-Wulf plant in Bremen. This facility manufactured the four-engine Fw-200 Condor, used as long-range reconnaissance aircraft, bombers, and transports, even for ferrying high command. The bombing inflicted critical damage on the factory, bringing production to a complete standstill. The loss of these manufacturing capabilities created serious problems for the aviation industry. Command was forced to urgently seek alternative solutions, as the demand for heavy aircraft to support operations, including those on the Eastern Front, remained high. The attention of Air Ministry officials turned to the Blohm and Voss factories. The enterprise possessed the necessary production capacity, skilled personnel, and experience in building large aircraft. The company was ordered to suspend work on its own projects and retool production to build the Fw-200 Condor under license. This was a direct order, not a suggestion. Despite the objections of company head Walter Blohm, the facility's resources and workforce were redirected to assemble another manufacturer's design. The relevance of the BV-141 project faded. The machines already built remained in storage out in the open, exposed to the elements. These planes never saw combat, and planned reconnaissance flights over Soviet territory never took place. A certain number of the aircraft were used for training purposes and testing new equipment, but no combat sorties were ever flown. Plans to deploy these asymmetrical scouts to the Eastern Front were never realized. By the end of the war, most of the BV-141 fleet had been dismantled or destroyed during the retreat to prevent capture by the enemy. In 1945, as Allied troops entered Germany, they discovered fragments of aircraft with a non-standard asymmetrical layout. The find sparked interest among technical specialists. British forces captured at least one surviving specimen and shipped it back to England. Royal Air Force engineers conducted a complete teardown of the design and a detailed analysis of its aerodynamic characteristics. The experts' verdict turned out to be mixed. The originality of the engineering concept and the quality of the technical execution were noted, but the specialists agreed with the German arguments regarding the difficulty of mass-producing such machinery and its vulnerability in combat. According to bibliographic data from technical reports, the U.S. Air Force Materiel Command also obtained access to a BV-141 specimen for testing. American engineers reached similar conclusions. The design was evaluated as an interesting experiment, but was deemed impractical for combat use. According to information from German archives, a total of 20 units of the BV-141 were built across various modifications, including prototypes and pre-production models of versions A and B. Most of the built examples made only a limited number of flights. Some of the machines were used exclusively for static ground testing of systems between 1939 and 1940. Not a single aircraft of this series has survived to the present day. All the equipment was destroyed during hostilities or scrapped by the Allies after their research was completed. Information about the asymmetric reconnaissance plane has been preserved only in the form of photographs, blueprints, and documentary evidence. After Germany's surrender, designer Richard Vogt came to the attention of American intelligence services as part of Operation Paperclip, the goal of which was to bring German scientists and engineers to the USA. Thanks to his experience in developing non-standard aircraft structures, Vogt was brought to America to continue working on experimental projects. His professional interest in unconventional aviation layouts continued. While in the United States, Vogt took part in developing concepts for bombers with nuclear power plants, vehicles designed to remain airborne for long periods without the need for refueling. Later, he moved to the Boeing Corporation as a civilian specialist, where he worked on various projects until his retirement. Thus, the designer of one of the most unusual aircraft of the Second World War concluded his professional career in the commercial aviation industry. The BV-141 took its place in the history of technology as an example of a non-traditional engineering experiment. This aircraft, known for its asymmetric configuration, remains a significant example of the alternative approaches to aerodynamics and design that engineers were considering in the mid-20th century in their search for optimal technical solutions.